Hello there, everybody. Welcome. My name is Emilio Kadaris, and I'd like to welcome you all to yet another installment of the Digital Home Systems webinar series. For those of you who are joining us live, welcome to the room. And for those of us who are going to be watching this on replay, welcome to you too. Today, we're going to be chatting about Z-Wave, and we're going to deep dive into what Z-Wave is and how that technology works at a fundamental level. So, as usual, we are going to have an opportunity for question and answer time at the end of this webinar. If you do have questions, feel free to type them into the chat window that you'll be able to see there on your screen. It should be on your right-hand side. And a little FYI about this particular session, the notes that you'll see up on the screen shortly are fairly content heavy. There are a lot of words on the screen, and I do not expect you to read them all. Likewise, I'm not going to be reading completely off them. The good news is that I do have a copy of this slideshow available for you to download. All you have to do is click on the Files section, just again there on the right-hand side of your screen, and you should be able to download that one there. If you can't do that in the live chat, webinar, not a problem. We will be able to pop it up on our webpage afterwards. So if you can't get them immediately, don't stress, they'll be there in the end. And for those of you watching on replay, you'll have them there as well. Okay, so without further ado, let's jump into it. So all about Z-Wave. This is going to be fun. Now, to start things off, it's probably a good idea to discuss what Z-Wave actually is. A lot of you would know or have heard of the word radio frequency before. Now, what radio frequencies are is that they range from a whole spectrum of different things, from the little remote controls that you would use to, let's say, switch on and off your TV or your garage door or something like that. And they range all the way up to what we know at the moment as Wi-Fi and microwaves, so like an actual microwave that heats things up, and all the spectrum in between. Now, they run on a number of different frequencies or different codes, and what that means is that each particular device has its own bandwidth and its own range of that spectrum to operate on. Now, you might have heard that Wi-Fi, or you might already know that Wi-Fi uses two main channels. They use a 2 gigahertz channel and a 5 gigahertz channel. Bluetooth also uses the same 2 gigahertz channel that Wi-Fi uses, albeit in a slightly different manner. But Z-Wave is unique in the sense that in Australia, New Zealand, Brazil, South Africa, Thailand, a couple of other countries around the world, very few number, it actually operates on 921 megahertz. And all Z-Wave does operate on a sub-gigahertz frequency. So they're not really high frequency transmissions, which is really, really good. And we're going to go into why that's important later on. But one thing that you need to bear in mind, everyone, is that when you're looking at Z-Wave from around the world, different countries and different regions in the world do have proprietary over certain frequencies. So in Australia and New Zealand, as I mentioned, 921 megahertz is what we run at. In the US, you can see up there on the screen, it runs at 908 megahertz. And in Europe, it's a completely different one again, it's 868. Now, the important thing to think about here, everyone, is that if you purchase products in Australia using the 921 megahertz frequency, they will only work with other products that run on the same frequency. Now, this is really, really important. If you are buying things from overseas and importing them into the country or getting them shipped through Amazon or Alibaba or eBay or anything like that, please, please, please make sure that it runs on 921 because if it doesn't, it is just not going to work. Unless your entire system runs on that frequency that you have purchased from overseas. Now, we're not going to jump into the legality issues that surround that. So, you know, it is technically not right to use, or illegal in some senses, to use frequencies that aren't listed as Z-Wave frequencies in this country. So yeah, please make sure that when you're purchasing things, you can purchase them within the country or within the region that you're looking for. Otherwise, it won't work really well and it just gets you into all sorts of trouble. Now, having said that, Z-Wave is by far the world market leader in wireless control, with, since its inception, which we're going to go through, has sold over 100 million products worldwide. And that's a lot. So that's all around the globe. It's really big in the United States, really big in Europe, and it's just starting to grow into something really wonderful here in Australia and New Zealand. So we're on the money. Okay. It was developed back in 1999 in Copenhagen by a company called Zensis. Since then, it has been purchased and repurchased and purchased again by a whole bunch of different companies, all upping the value of Z-Wave as they go along. So the most recent one was back in 2018. Silicon Labs, who you might know as the world's biggest manufacturer of wireless radio frequency chips. They produce Wi-Fi, Bluetooth, Zigbee, all sorts of different technology. They purchased Z-Wave for $4 billion plus capitalization costs in the US. So $4 billion US plus capitalization. Now, I don't know where everyone's financial status is out there in the world, but $4 billion US is a lot of money. So the good news is that since that purchase has taken place, we've seen leaps and bounds in terms of the research and development and deployment of Z-Wave technology since then. So it really is big ticket. It's something that's going to really grow from here on in. Now, as I mentioned prior, Z-Wave does operate on that sub-gigahertz frequency, and it does allow for a couple of different things or different features and different benefits because of that. Now, we're going to go through them step by step, but you can see them here on the list. We've got mesh networking, interoperability, security, certification, power consumption, lots of different types of devices, and it's open to the public. Now, these things are not all completely unique to Z-Wave nowadays, because a lot of other technologies are starting to use very similar concepts, like mesh networking, for example. You start to see it pop up, and some of the things that we go through in security will seem fairly familiar to you. Or it could be completely new, and that's okay. But what I'm trying to get at is that Z-Wave did pioneer a lot of this space, and as it has grown, a lot of other technologies have jumped on board. And now that Silicon Labs owns it, it's essentially open slather. So everyone's going to learn off everybody else, and they're all going to adapt each other's technologies. So let's jump into what each one does. Now, mesh networking, for those of you who are new to the concept, the best way to describe a mesh network is to consider a central point, so a hub in this situation, which would be your Z-Wave hub. You could have a Vero branded one, you could have a Fabaro branded one. Brand is pretty much irrelevant. If it actually runs off Z-Wave, this is what it will look like. So if you imagine my thumb as being a Z-Wave hub, you're then going to have a whole number of different devices that you link into that hub. The good news is that each device, so long as it is a fully powered or a constantly powered device, they usually run off your 240 AC, like light switches, dimmers, RGBW controllers, and your plug-in switch. But you can also get range extenders as well, which operate in the same manner. If they are constantly powered, what they do is they then repeat the signal. So every single light switch that you'd have in that installation that's connected to that hub then almost acts like a little repeater itself, making every device talk to or communicate with one another. Battery-powered devices, unfortunately, do not repeat the signal, but they are in the mesh network, so they do help establish a really strong and robust network where the gateway can use a number of different pathways to get to where it needs to be. So it's a really, really awesome technology. It's something that Wi-Fi is just starting to pick up, with a couple of really higher end routers are starting to use similar concepts to mesh networking. But essentially what it allows is it allows for a very low powered, low data transmission, but really, really strong and reliable network. Another thing to bear in mind is that one mesh network of one hub can usually have up to 232 different devices. Now, we wouldn't recommend having one hub control 232 devices because that is a lot of work for one hub to be able to control, but that is theoretically what it's able to do. That's what Z-Wave allows it to do. So it's a really, really, really good network to start building your installation off. Interoperability is another one of these concepts. Now, this one is quite detailed, but I'll try to make it really simple for you. Interoperability means that a device which was produced with, let's say, an older chip, so we'll just pick a year at random, we'll say it was produced in 2010. It's 2020 now, so a device that was made in 2010 will be guaranteed to work with a device that's made in 2020, and that's what that interoperability means, even though they might be using different chips. So let's say the newer one is using a Z-Wave Plus chip, which is we also call the Z-Wave 500, but it might also, and the older one might be using a regular Z-Wave chip, which could be the Z-Wave 300 chip. Now, even though they're different chips, they will still work together for the purpose that they are designed to have. And the reason why I say that is that you will see there on the slides, Z-Wave ensures interoperability between the products, but it doesn't guarantee compatibility. Now, what that means is that while those two devices will work with one another, you might not get all the features that come with that device. I'll give you an example. A light switch is designed to switch lights on and off. That's pretty much all it has to do in order to be a certified Z-Wave light switch. Switch things on, switch things off. Some newer light switches also have the capability to track energy usage, and they might be able to do a couple of other fancy things with reporting. Now, if you have one of those older light switches which just switches things on and off, and you have a newer light switch which has compatibility, which has all the fancy reporting, your gateway might only support switching lights on and off. It might not have the ability to have all those new fancy reports that you can get with it. So in that sense, the gateway that you own will be able to switch both switches on and off, but it might not have all those extra features that the newer one has. So when you've got your customers saying, oh, look, I can see that this is all really good and it all connects quite nicely, but will I have to replace it in 3, 4, 5 years time? The answer is no, you don't have to. If they want to have all the new features that all the new devices have, well, then that makes sense. They'll have to update their devices. But interoperability means that these are almost future-proofing themselves, and they're allowed to work with each other from previous generations. So it's another huge positive, and it's something that's really unique to Z-Wave technology. Wish iPhones did that. Shout out to Apple. Okay, so security is another big one. One question that we get a lot is, are wireless devices secure? Is someone going to hack into my home and unlock my front door, or switch on my lights at random? The answer is no. There are a number of security pathways that Z-Wave uses built into the actual chip that allows that to not happen. One of them is that they use AES 128-bit encryption. Now, that's the same level of encryption that's used in online banking. So in online banking, it's very difficult for someone to hack into your account unless they have your username and password. Same applies for Z-Wave networks. Unless they have your username and password, they can't hack into your system. So don't give strangers your username and password, and don't post it up on the internet for all to see. But some newer devices also have S2 level of encryption, which takes that level even further, okay? Now, another really beneficial thing is that every gateway comes with its own home ID. It's a very unique number. It's made up of numerals and letters, and all those things come together. Before we go into that, what that home ID does, what the gateway does, is that every time you have a node or a device that connects to that home ID, it actually shares that ID with the devices that you connect it to. So every light switch will have a shared ID with that home ID. Every battery-powered device, every lock, they're all going to be sharing that same home ID with that gateway. So what that means is that one gateway and all the devices have the same ID. They have 128-bit level encryption. If they're newer devices, they might even have S2 level of encryption. And it means that you can have a setup in one home or one apartment in a big building, and the next apartment can have a completely different setup, and neither one of them will interfere with one another. They can't hack into one another's devices either. So it's one thing. It's one thing to have a level of security from an encryption point of view, but it's another thing to have it where you're sharing IDs as well. And again, that's something that Z-Wave has had since day one. So it really is a pioneer in the space of security. Let your customers rest very, very easily, and for you as well, please rest easily. This is not a system that can be easily broken into, unless they have usernames and passwords. So please don't share those willy-nilly. The next big thing about Z-Wave is certification. Now, there is a big overarching body of Z-Wave called the Z-Wave Alliance. That is where every manufacturer of Z-Wave devices and a number of distributors and installers, us included, are part of that alliance. And we all work together to help increase the profile and make Z-Wave more popular and keep it as very well regarded around the world in home automation. What certification does through the Z-Wave Alliance is that it makes sure that every device that gets that certification stamp works the way it's supposed to. So they have to have that interoperability. They have to have that level of security. They have to work across brands. So a Qubino product has to work with Fibaro, and Fibaro has to work with Qubino, and all that sort of thing. Now remember, it doesn't mean compatibility. So some of the features might not work, but they should be able to switch each other on and off. And that's something that certification allows. So at the moment, worldwide, there are 2,100 or over 2,100 certified products, and that does keep growing every single day. In Australia and New Zealand, we have access to around about 150, and that keeps growing as well. So if you see stuff from overseas and you say, hey, I can use that in my installation, please bear in mind that the frequency has to be 921 megahertz, and if it isn't, it will not work. But there are tons of devices, and manufacturers are constantly expanding into new marketplaces. So it's a really exciting place to be. And just for a little plug on us, we do tend to get the news about products coming to Australia first. So keep us on speed dial whenever you're looking for something new. A few more slides to go, everyone, and then we open up to question and answers. What we have next is power consumption. Power consumption is something that Z-Wave prides itself on because they use such small levels of data transfer. Now we're talking bits, not bytes or megabytes or kilobytes or anything else. We're talking bits. So they're really, really, really small levels of information, or little packets of information that get sent from a gateway over to a light switch to tell it to switch on. That means that for the battery-powered devices, the efficiency is through the roof. To give you an example, a coin cell battery inside a motion sensor, for example, is rated to last years, not months, not weeks, but years. And as a little plug for the lock that I have at home, I've got one of those smart locks that you might be able to see behind me there, the Yale digital deadbolt. We haven't changed the batteries in about 18 months, and people are constantly walking in and out of the house. So it's they're really, really, really good with their battery usage. Now, of course, your gateway will tell you when your battery runs low, so it's not like you're going to be caught off guard. All you have to do is just go in, change the battery, and then you'll be good for another really long period of time. Now, I should say that the more you use a device, clearly the faster the battery is going to run out. So if you are experiencing that, there are lots of things you can do. Please get in touch with us and we can help you through that step by step. Not today though. Today is just about Z-Wave. Alrighty, almost there. Multiple types of devices. So as I mentioned earlier, you have tons of different devices available. There are about 150 different devices or so here in Australia. I think it's a bigger number than that, but last I checked it was at 150. We've got battery operated devices, which are the ones that don't send on the signals. They don't participate in establishing that mesh network, but they will be things like security sensors, humidity sensors, door window sensors, recessed sensors, generally sensors, and also smart locks are usually battery powered as well. But then you can get things that are hardwired or constantly powered. So they're going to be operating on either the 240 volt AC current, which is the stuff you get straight out of the wall, or it could be a 12-volt DC. Irrespective, they're constantly powered. They do participate in strengthening up the network. So one hot tip for you is when you are setting up a Z-Wave network for the very first time, and even if you're doing it for the 100th time, for the 1000th time, best practice is to get your gateway in the center of the installation, not in the center of the house, but in the center of the installation, and then start getting all your hardwired devices set up first. That will create a really strong framework for your network, and then once you've got a strong mesh, you can start including your battery powered devices, and you're less likely to have that annoying little message that pops up sometimes of cannot detect device. So increase your range, get a nice strong network, use those hardwired devices first. Finally, everybody, Z-Wave is open to the public. So as we mentioned earlier, because there are so many different manufacturers and because they all come together under that Z-Wave Alliance banner to receive that stamp of certification, it does mean that a number of different companies can all come together and produce products. So you might see a couple of different brands. If we go back to light switches, we sell at the moment AOTech switches, Cubino switches, Fabaro switches, and look, there could be other brands that come into the forefront as well. All that means is that essentially it's good to have that little bit of healthy competition. Each manufacturer will have their own little spin, so you know, one brand might do something a little bit differently to the other brand, but it does mean that it keeps them all honest and it stops people from having a monopoly over the marketplace. Whenever that happens, we generally find technology, you know, starts to either fall off to the wayside, or you know, they don't put as much money into research and development, or there's the risk that they'll stop business altogether, and then all of a sudden the whole platform disappears. Not to name any names, but that has happened to other home automation technologies in the past. So whenever you have, and that's dreadful, you know, it's dreadful when it happens, especially from a consumer's perspective. You know, could you imagine everything just going offline one day? It's not going to happen with Z-Wave, because when you have that open to the public platform and that certification platform, generally speaking, it means that if someone does drop the ball a little bit and falls out of the market, someone else comes in and takes their place. So it's a really, really good thing. Really, really good. Now, I've got a little list here, but realistically, it's your imagination that tends to be the biggest constraint when you're designing a Z-Wave network. You've got thermostats, lights, plug-in modules, door locks, all the different sensors that I mentioned before. Smoke detectors, water shutoff valves, alarm panels, only some of them, not all of them. You've got motorized shade control, you know, there's motorized gate control. So there's a whole bunch of different things. You do need a gateway first. That is an integral part because it creates the brain of your system. But then as that expands out into the network, there are so many different options and so many different applications for Z-Wave. So think about it. Next time you're at home, or next time you go to a customer's house, have a look around and see what they can do. You know, some smart examples are, you know, just getting a good old-fashioned power switch. Geez, I've lost the word. A power outlet. You know, the ones that you just plug in things into the wall. You could easily pop a Z-Wave relay behind that, and all of a sudden you've converted that power outlet into a smart switch, which could potentially track the, if it's a newer product, it could potentially report to the customer all the different types of energy usage and all that sort of thing, and then also be able to switch things on and off remotely, or to a schedule or to a scene. So yeah, it really comes down to your imagination. Now, you can see here in front of you, it's Q&A time, so I'll hang around. We don't have any questions at the moment, and again, that will either mean that you all understood perfectly, or you just don't have any questions right now. Bear in mind though, everyone, that you can definitely email questions through to us. I will come back and check that chat platform in a second, but in case you want to email your questions through, here are some email addresses you can send them through to. office@digitalhomesystems.com.au or office@dhsys.com.au is probably the best one. Following that, this is my email address down underneath it, and then we've got Jersey, who's one of our directors here. If you send it to all three, someone will be able to respond to you really quickly. If you send it to just one of them, it depends on who sees the email first. But I know you all know how emails work, so don't need to go into that one. If you have any installation queries, or if you are an electrician yourself, or if you want to see how we put together smart lighting modules, so a relay connected up to a light, and see how that all works, and have best practice and hot tips for a number of different lighting installations, that's going to be a really good one for you. We are going to get far deeper into the nitty-gritty with that one. You're going to be able to see how things are wired up. So it's going to be a really, really good one. Either way, that does bring us to the end of today's webinar. So I'd like to thank all of you who are in the live room. Thank you so much for attending. For all of you watching on replay, thank you so much for making it all the way through to the end. And I look forward to seeing you at the next webinar. Goodbye for now.